Hello everyone, welcome back to our channel. We were discussing about complex numbers and quadratic equations from class 11th Maths NCERT. Last class we saw Z inverse into mod of Z square is equals to Z conjugate. We know that Z inverse is equals to 1 upon Z. So this can be written as mod of Z whole square upon Z inverse is equals to Z conjugate. Taking Z inverse on right hand side, mod of Z square is equals to Z conjugate into Z inverse. Now in this class we will encounter a few formulas, and all the formulas are important. Next, there are some properties of these modulus functions, modulus complex numbers. So addition of two complex numbers, addition of mod of two complex numbers. So if you add two complex numbers and then take their mod, that value is and then take their conjugate, that value is equals to Z1 conjugate plus Z2 conjugate. Similarly, if you subtract two values and take their conjugate, then that will be equal to taking first value's conjugate minus taking second value's conjugate. Multiply two values, two complex numbers, Z1 into Z2, and you take the combined mod of it, that is equivalent of taking individual mods and then multiplying. The rule also is extended to division. Z1 upon Z2 whole modulus is equals to mod of numerator upon mod of denominator. Observe, in all these formulas, the left hand side and right hand side will always end up to or will always give you a conjugate value. Next, if you multiply two values, if you multiply two complex numbers, Z1 and Z2, and if you take their combined mod, conjugate, then that is equals to first value's conjugate multiplied by second value's conjugate. So this formula is same as the mod formula. Here you're taking mod of both the value, mod of multiplication of both values, that is equals to mod of multiplication of individual mods. Here, combined conjugate of multiplication of two complex numbers will be equal to multiplication of individual conjugates of the same complex numbers. Division rule says if you take Z1 upon Z2 and then take the conjugate, that is equivalent to taking Z1's conjugate upon Z2's conjugate. Next, here in the division rules, it's compulsory to write that the denominator is not supposed to be 0. That means mod of Z2 will not be equal to 0, and here also conjugate of Z2 will not be equals to 0. If you take Z inverse and take another inverse of it, you'll end up with the same complex number. Similarly, if you take a conjugate of Z and then take another conjugate of that result, you get the same original complex number. What if you add a complex number with its conjugate? This will lead you to 2 times real value of Z. All of these can be proven with the help of examples. So if Z is equals to say A plus I B, then Z bar conjugate is equals to A minus IB. If you add them together, then this value, these two will get cancelled and you're left with 2A. A represents the real part of Z. Hence, this addition value is real part of Z. If you subtract these values, Z minus Z conjugate, then what happens? The real part vanishes and the imaginary part is left. So 2I imaginary part of Z. Next, if in this particular result, or if in general, your z value is equals to z bar, z conjugate, what does this mean? Z is equals to a plus ib, and z conjugate is equals to a minus ib. These two values can be equal only when these two vanishes. This means this is possible only when z and z conjugate, only when z is purely real. What if z is equals to minus z conjugate? This is only possible if z is purely imaginary. Next, we know that z is equals to a plus ib, and z conjugate is equals to a minus ib. This means that if we add these two values, if we add first value with the second value, just one second, here, we are trying to prove these results. How z plus z conjugate is equals to 2 times real value. We have done it with the help of an example. Here also you'll encounter z, I think there's no need for this. Z plus z conjugate is equals to 2 times real. This is what you wrote in the previous, what we wrote in the previous page. 2 can be taken over here, and real part of z is equals to z plus z bar upon 2. So this is another way of looking at it. It means the real part of z can be expressed as the average of z and its conjugate. Similarly, z minus z bar conjugate is equals to 2i imaginary part of z, which means that if 2i is taken on the left hand side, imaginary part of z will be equals to z minus z conjugate upon 2i. This value is equals to a, and this value is equals to b for any z is equals to a plus ib. Next, we know that z into z conjugate is equals to modulus of z whole square. We also know that modulus of z means root of a square plus b square, and modulus of z whole square means this whole square. This value will be equal to a square plus b square, and a represents real part of z. We're taking its whole square plus imaginary part of z, and then you're taking its whole square. So real part square plus imaginary part square. It's just another way of looking at it. Now, if z is a function of z1, both z and z1 are complex numbers, then z conjugate will be a function of z1 conjugate. Z plus z conjugate. Now this value we have already proven is equals to twice of real part of z. This value will always be less than or equal to 2 times modulus of z. 2 multiplied by mod z. Next. Z1 plus z2 whole square. Now this we already know is equals to z1 square plus mod of z2 whole square plus 2 times real value of z in z1 into z2 conjugate. If you take minus over here, only this term will have minus sign. This rule is called as cosine rule. Mod of z1 plus z2 will always be less than equals to mod of z1 plus mod of z2. This rule is called as triangle inequality rule. There's also a parallelogram rule which states, or parallelogram law which states that mod of z1 plus z2 whole square plus mod of z1 minus z2 whole square will be equal to 2 times mod of z1 square plus mod of z2 square. This is parallelogram law. If you want further explanations of any of these formulas, let me know in the comment, so I'll make a video on it. This parallelogram law is derived from a general rule. You need not remember it. The general rule states that mod of A into Z1 plus B into Z2. Let's write the minus sign, minus term first. Minus B into Z2 whole square plus mod of B into Z1 plus A into Z2 whole square. This value will be equal to A square plus B square into mod of Z1 square plus mod of Z2 square. Here, if we substitute A and B, both values are 1, we'll end up with a parallelogram law. Next. Next rule states Z1 into Z2 conjugate plus Z1 conjugate into Z2. If you take something like this, you will get 2 times real value of Z1 conjugate into Z2, which will also be equals to 2 times real value of Z1 into Z2 conjugate. Now, the formula is also valid for negative value. First term minus second term. Mod of Z1 minus Z2 will be always greater than equals to mod of Z1, mod of Z1 minus mod of Z2. The outer mod suggests whatever value inside you get, you take the mod of it. Now, if you have Z and Z bar, your mod of real value of Z will always be less than or equals to mod Z. Similarly, the imaginary value of Z will also be always less than equals to mod Z. So this concludes a few list of formulas that are important. In the cosine rule, you can also write, let's modify one rule, this cosine rule. But this value over here is mod of a complex number whole square. So we know that from our basic understanding that Z mod Z whole square is equals to Z into Z conjugate. So this value can also be written as inside value Z1 plus minus Z2 and multiplied with conjugate of it, Z1 plus minus Z2 conjugate. So that's it. That concludes your formula list for conjugate and modulus. Some other formulas related to conjugate and modulus also exist, but that we'll cover in the next class and henceforth. Thank you.